I will save you using rotational motion and conservation of energy. Wow, you saved us. That's right, girls. I know all about the physics.
How did Wilkie know how far away to hold the string? If you hold the string too far, the mass doesn't fall, and if you hold the string too close, the exact same thing happens. In order to understand this, we must draw a force diagram. Now, initially, right as the mass is at the very bottom, there are two forces of gravity. The first one is of the weight of Mrs. Wilkie, and the second one is of the weight of Cheryl and Ellie. And with this, of course, there's two forces of tension holding them up. Now, when it's finally there, when the string has wrapped all the way around and is at the very top, forming a 180-degree angle with the bottom, there's a force of gravity, and there's also a force of tension that can also be drawn as a centripetal force. Now, for today, we're going to be calling this L and this H. And so in this case, this would be L, and then this part right here would be L minus H, which is also the radius of the circle.
Conservation of energy. We're going to use the basic energy equation without the energy dissipated, even though there probably was some friction. Understanding that there was no initial kinetic energy, so we sub in mgl for potential energy, and we're going to use L minus H for the radius of the orbit, multiplied twice. Yay. We're going to cancel out the m's and rewrite the equation. And then we're going to factor out the 1/2 to make it a 2 on the opposite side and get the velocity squared by itself.
Next, you use rotational motion. I wrote circular motion, but pretend it says rotational. You use the equation that the centripetal force is equal to the force of gravity. I wrote F net, but pretend that says Fg. So I used the centripetal force equation, and then of course I used mg for the force of gravity. For the velocity squared, I just plugged in the velocity squared that we found just now into the equation. And then, of course, I set that equal to the force of gravity. I then realized that I wrote F net instead of Fg, and so Ellie, as usual, gave me the whiteout. Love the whiteout. Live by it. Anyways, then I put the Fg. And then I realized that with that equation you could cancel out all of the m's, and then you could rewrite the equation. So the point of doing this is to find the ideal ratio between L, which was the length of the long string, and H, which was the length of the short string, in order to C. And so you end up getting that H is equal to 3/5 L.
And that's how Wilkie used physics to save us from the flaming fire of failed physics. Incredible. She'll be the star of the show.